Okay, so we're going to add two more trigonometry ratios to our arsenal. All right, and those are sine and cosine. Okay, a trigonometric ratio is a ratio of two sides of a right triangle. We've already seen one of those trigonometric ratios, right? Tangent relating the opposite leg and the adjacent leg. All right, we've already seen one trigonometric ratio of the tangent. There are two additional trigonometric ratios. Actually, there's three more beyond the three that we talked about right now. Those other three aren't super important. If you understand sine, cosine, and tangent, then you'll be fine with the other three too. I don't think we're going to touch on those here. We might, maybe, I don't know, but probably not. You'll definitely see them later in your math career, though, should you continue on, taking mathematics and stuff like that. We're going to focus on tangent, sine, and cosine, though. Okay? So, sine and cosine both involve using the hypotenuse of the right triangle, right? Tangent ignored the hypotenuse, focused on the, if there was angle A, tangent of angle A would be the opposite leg, BC, over the adjacent leg, right? Always focused on the legs. Sine and cosine use the hypotenuse, okay? The sine, S-I-N-E, of angle A, written sin A, we'll pronounce it sine A, is defined as follows. Sine of A equals the length of the leg opposite angle A. So sine of A is the opposite leg, so BC, over the hypotenuse, AB. Okay? Cosine of angle A, so cosine, okay, is the leg adjacent to angle A over the hypotenuse. Okay, just like that. And so then putting those all together, we have this like mnemonic device, SOHCAHTOA. Okay, and that mnemonic device can help you remember the different trigonometric ratios. Sine is the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse. And tangent is the opposite leg over the adjacent leg. SOHCAHTOA. Okay, sounds like something you might chant around a campfire, like in the midnight hour or something like that. SOHCAHTOA. So Okay, 2 laughs, good. So anyway, and please make sure you spell it correctly, right? I was in my geometry class back in high school, and I was taking the trigonometry quiz, I think, and I misspelled it. I think I spelled it like SOHCAHTOA. I did T-A-O, I think, at the end instead of T-O-A, and I got like a D on the quiz or something like that. I remember because I misspelled SOHCAHTOA, right? So make sure you spell it correctly, or else it's gonna, affect how you set up your ratios and then mess you up. So please make sure you remember that. Okay? But that's a mnemonic device to help you remember things. All right. You can use these definitions to calculate trigonometric ratios. So, example 1, we're going to write sine and cosine of each angle as a fraction or as a ratio, right? And then also as a decimal to the nearest thousandths. So we'll look at angle D here. We're going to do sine and cosine of angle D. Okay? And they've already got it for us here. So sine of D is the opposite leg over the hypotenuse. So the leg opposite angle D, 8 over the hypotenuse, 17. So 8 over 17, which is about 0.471. Okay. Cosine of angle D. Cosine is adjacent leg over the hypotenuse. So adjacent leg to angle D is 15 over the hypotenuse of 17. So there it is, 15 over 17, about 0.882. Okay. Let's try one on our own here then. Okay. So angle F. So sine of F is equal to, again, the opposite leg. So what is the measure of the opposite leg to angle F here? 15 over the hypotenuse. What's the hypotenuse of this triangle? 17. Okay, which is approximately 0.882. I'm just going to steal that same ratio right there. All right, let's talk about the cosine of angle F. Okay, cosine is adjacent leg. What's the adjacent leg to angle F? 8. What's the hypotenuse? 17. Okay, so we get 0.471. Okay. What do you notice about the sines and cosines that you found? Do you see any relationship between these two and these two? The sine of angle D is the same as cosine of angle F. And the cosine of angle D is equal to? Yeah, the sine of F. Okay? Will this be true in general? Yes. Yes, it will be true. Okay? And we can kind of show it the same way we showed it yesterday. If I just draw a generic triangle, a generic right triangle, we'll call it ABC. Okay? The sine of A, in this case, will be BC, opposite leg over hypotenuse AB. The cosine of angle A will be the adjacent leg AC over the hypotenuse AB. And then if I do the sine of angle B, sine of B is the opposite leg AC over the hypotenuse AB. And the cosine of angle B is the adjacent leg BC over the hypotenuse AB. And you can see how they relate there. Right? You can see that relationship. Sine of A is BC over AB. Cosine of B is BC over AB. Cosine of A is AC over AB. Sine of B is AC over AB. Okay? It did not require that we had anything else but a right triangle here, so of course this will be true in general. The sine of one of the acute angles is equal to the cosine of the other acute angle. The cosine of angle A is equal to the sine of B. Okay? So on and so forth. All right? So, number 5, in a right triangle, triangle PQR, with PR equal to 5, QR equal to 3, and measure of angle Q is 90 degrees, what are the values of sine of P and cosine of P? What might be a good idea here to do to solve this problem? What should we probably do when we go about solving this problem here? What should be a good strategy? Silence would not be a good strategy. What will we do? What can we do here to help us solve this? Jenny. We want to figure out what sine of P and cosine of P are. No idea? Okay. We've got a right triangle. We got these measures. We have this angle. We want to find the sine of P and cosine of P. Do we give up? Say, I don't know how to do this. This will just show me. What might be a good idea to help us solve this problem? Draw a picture! There we go. Yeah, draw a picture. Maybe I was asking the question in a weird way. I know sometimes like I don't ask the question very well too, so you're like, I'm not really sure what Mr. Wigmeyer wants, and I don't want to say this because it might be wrong. But no, yeah, I just wanted you guys to say draw a picture. Yeah. Okay. So we'll draw a right triangle here. Q is the 90-degree angle, so let's label it correctly there. Okay. PR, so we'll just say that's P and that's R there. We'll say PR is 5. And QR is going to be 3. Okay. Question?
I just want to just give you the hypotenuse. Yeah, it does that for me too. It just says the hypotenuse is 5. It doesn't give us anything else.
Neat. Okay, so there are, especially for your class, for whatever reason, there are like 2 versions of this textbook floating around. I guess you guys have a different version. So, because some people have what I have, right? Does anyone have what I have up here? Yeah, okay. So for whatever reason, you guys got lucky. You got the different version. So I apologize to those of you that don't have that information. You can't do it otherwise, I guess, right? I mean, that's all you were given was the hypotenuse.
It says measure of Q is 90 and PQ is greater than QR.
Interesting. I still feel like that wouldn't be enough information, though. So, anywho, my apologies. Now I realize, now I understand why some of you guys weren't sure what to do there because, yeah, that is weird, okay? But there is what we want to do. Okay, so what are the values of sine of P? Okay, so sine of P would be what over what? 3, opposite leg, over 5. Yep. Okay, or if you want to, you could say 0.6. Okay, what about cosine of P? What's that going to be? Avery? 4 over 5. But Avery, this is missing the leg measure here. How'd you know that?
3, 4, 5.
It's a 3, 4, 5 triangle, yeah. Pythagorean triple. 3, 4, 5. So that's like a 0.8 there. How could we have found this missing side? Pythagorean theorem. A squared plus b squared equals c squared. Right. And it would end up being 4. Very good. Very good. Okay. Again, feel free to use that SOHCAHTOA. Okay. My geometry teacher joked, and maybe it's not a culturally sensitive joke, so maybe I shouldn't say it. So moving on. All right. Next one. All right. Using complementary angles. All right. The acute angles of a right triangle are complementary. Their trigonometric ratios are related to each other as shown in the following relationship. Right. We've talked about this already. The sine of A is equal to the cosine of B. The cosine of A equals the sine of B. And just for our purposes, I'm going to go ahead and also state the tangent. The tangent of A equals 1 over the tangent of B, right? The reciprocals. Right? Tangent A's ratio is equal to the reciprocal of tangent B's ratio, 1 over the tangent of B there too. And vice versa. Of course, you could say tangent of B equals 1 over the tangent of A as well. Okay? That's all there is to it. Okay, so we're going to use this here just real quick. Given that the sine of 38 degrees is approximately 0.616, write the cosine of a complementary angle in terms of the sine of 38 degrees. Okay, so if the sine of 38 degrees is equal to about, I'll approximate that, about 0.616, then the cosine of what angle will also be 0.616? 52, the complement of 38, 52, right? Just do 38, take that away from 90, and you're left with 52. So there's that same idea there. Okay? Let's try this one. The cosine of 60 degrees is equal to 0.5. We want to come up with the sine of what angle then is equal to 0.5? So if the cosine of 60 is 0.5 or 1/2, the sine of what angle must be also 0.5? 30 degrees. Okay, because 60 and 30 are complementary, so if cosine of 60 is 0.5, sine of 30 must also be 0.5. And this is true. Okay, this is true. Okay, this is a fact that we may, you'll be certainly learning about in pre-calculus and maybe algebra 2. Again, if you decide to move on to pre-calculus and stuff, you're going to be using this to help you out too. Okay? So the sine of 30 degrees is also 0.5. All righty. So why don't you guys go ahead and try 8 and 9 here real quick, okay? Do those same things. Given the cosine of 73 is 0.292, write the sine then of a complementary angle to match that. So in other words, fill in the blank here. Sine of what is approximately 0.292? And then here, the cosine of what is equal to 0.707 approximately. Okay, fill in those blanks there for me. Okay, take like 30 seconds to do that. Go ahead and take 30 seconds. Answer those blanks, and then we'll move on to sides. Solving for sides. All right. Time's up. Colin, do you have an answer for number 8? Not really sure? So if the cosine of 73 degrees is equal to approximately 0.292, then the sine of what angle is going to give us that same ratio? Okay, Jackson, you want to help us out here? What's it going to be?
Oh,
Yeah, sorry, Jackson, go ahead. Yeah, 17. No, that's okay. 17. Okay, so just essentially it's the complement they're calling, the complement. Okay. So then, Colin, can you give me for number 9? If the sine of 45 is about 0.707, the cosine of what is going to give us about 0.707? Right. Very good. Just their complements. That's all that's asking for. All right, questions on 8 or 9? Ready to move on to solving for some missing sides now? Okay. So, got another ramp we're talking about here. A 12-foot ramp, again the 12 feet is the length of the hypotenuse there, is installed alongside some steps to provide wheelchair access to a library. The ramp makes an angle of 11 degrees with the ground. Find each dimension to the nearest tenth of a foot. So we want to find the height. We want to find the horizontal length. Okay, so let's say we want to find the height of the wall here. Given this angle, 11 degrees, okay, what is x in relationship to that 11-degree angle? What side is that? Is it an opposite leg, an adjacent leg, or hypotenuse? Opposite. Okay, and so what trigonometric ratios have opposite in them? Tangent does, and sine. Sine does. Sine has opposite, and tangent is opposite. Yeah, sorry, opposite. Okay, so which trig ratio do we want to use then here? Do we want to use sine of 11 degrees, or do we want to use tangent of 11 degrees? So do I want to say sine of 11 degrees? Sine of 11 degrees would be what ratio? X over what? 12. If I said tangent of 11 degrees here, it would be x over y. And what's the problem with this? Two variables. So could we use tangent? Yes, but it's not helpful because we have two variables. So we're not going to use tangent there. We use the sine. Okay? So how do we solve for x here? What should we do to both sides? Yeah, multiply by 12. So you'll see now the steps are very similar to what we did with a tangent. So we'll do 12 times sine of 11 degrees, which is approximately, we'll say, let's see, round to the nearest tenth of a foot, so 2.3 feet. That's x. Okay. Now that we have x, could we use tangent? Now we could. We could say tangent 11 equals 2.3 over y. We could do that and then solve for y that way. Okay, so we could say now tangent of 11 equals 2.3 over y and solve that way. Or what other trig ratio can we use to help us solve for y? Cosine, because y is the adjacent leg to that 11-degree angle, so we can say cosine of 11 degrees will equal what over what? The adjacent leg y over the hypotenuse 12. Okay. I like the cosine in this case because all we got to do is multiply both sides by 12. So we'll multiply by 12, multiply by 12. We get y equals 12 cosine of 11. And so we get about 11.8. Okay, and that's feet again. Excuse me. Question, Dylan.
How are you multiplying the 11 and 12? Like to get all of
It's not, so the 11 times the 12 is not what we do. We do 12 times the cosine of 11. So maybe I should show you my calculator here, what I'm typing in. So do you see that here? So for example here, right, it was x equals 12 times sine 11, so I did 12 sine 11.
Yeah.
Makes more sense now? Yeah. The 12 and the 11 can't be put together here because that 11 is inside of the sine, and we can't just bring the 12 inside the sine. So it's not sine times 11, it's sine of 11. 11's inside there, so we can't easily bring that 12 in. Okay? Other questions on any of that? Thank you for asking that, Dylan. So far, so good? Okay. Let's keep rolling here then. So, number 10, before we move on here, number 10 asks, could you find the height of the wall using the cosine? So let's go back to our problem here. I like this question. We found the height of the wall, x. We found the height of the wall using sine, right? To find x there, we used sine of 11 degrees equals x over 12. Could we have found the height of this wall using the cosine ratio here? And if so, how? So, Madison, what do you say?
Find y, which is the adjacent, so you would do
So that would give us if we knew that would give us y. But again, we want to find the height of the wall. Can we use cosine to find the height of the wall though?
And you can use Pythagorean.
Okay, use Pythagorean theorem. I see what you're saying. Okay, so in that sense, okay, so cosine combined with Pythagorean theorem. Can we use cosine just by itself to solve for the height of the wall? Avery?
You could have done cosine of 79, and then that cosine of 79 equals x over 12.
So yes, 79 degrees, that angle is this angle right here, angle C. So we could find, using the 11 degrees here and the 90 degrees here, we could figure out that this angle here is 79 degrees. X, the height of the wall, is the adjacent leg to the 79 degrees there. And then we can use that in conjunction with the hypotenuse. So that's another option, yes. So we could use the cosine using Pythagorean theorem, or we could use the cosine by itself. So good job there. 2 different strategies to do that. Very good. Okay. So I'm not going to write all that out, but 2 strategies there: cosine with Pythagorean theorem or cosine with angle C. All right, I've got one here for you to try though. Number 11. All right, you're asked to suppose a new regulation states that the maximum angle of a ramp for wheelchairs is 8 degrees. At least how long must the new ramp be? Okay, that's kind of a complex sentence there, but round to the nearest tenth of a foot. So solve for Z. Solve for Z. Okay? So think about what trigonometric ratio you're going to use. I'll write them out here. SOHCAHTOA. Okay? Think about what trigonometric ratio you are going to use to solve for that missing side, Z. Okay? And then set up your trig ratio and solve it. And I'll kind of come around and help if you get stuck. We're rounding our answers to the nearest tenth of a foot. Okay, so what angle are you going to use here? This is the first question. You want to use angle C? So what is the measure of angle C? 82, right? Okay, so I'm going to write it. Okay, now, we know this is 2.3. What is this side in relationship to the 82 here? Is the opposite leg, adjacent leg, or hypotenuse? Adjacent leg, okay. And we want to solve to find what? So what trig ratio incorporates adjacent leg and hypotenuse? So that's the one to use there. Make sense? Looks good, looks good. Yep. Now, you know what to do from here? We need the x by itself. So what's with the x that you need to get rid of? So, you said, okay, I see what you're saying. So you go, I'll come back to it. Now, it's 8, right? So you said 82. So we're just really careful. So, this 8 is an angle measure. We set up our 2 inches. And is the opposite leg over the adjacent leg. So if you're going to do tan 82, that's the opposite leg. What is the leg opposite to 82 degrees? setup is right, so good job. Yeah, you don't take tangent over 90 degrees here. Problem with tangent, because tangent requires you to have an opposite leg, but the opposite side to the 90-degree angle is not a leg, it's a hypotenuse. So you don't want to use tangent over the 90-degree angle. You want to use one of your acute angles. So, okay, so you sine of what angle? You're going to put an angle in there, 8 degrees. So why don't you put the sine of 8 degrees? Okay, equals. Now, sine is what over what? So what's the opposite leg? Over the hypotenuse. What's hypotenuse? Yeah, there it is. Perfect. Well, it goes like this. It's by itself. Yeah, good job. Perfect. What's with the z here that you need to get rid of? It's z times sine of 8 degrees. How do you get rid of times sine 8 degrees? Divide both sides by sine 8 degrees. That's all you gotta do. Yep. Perfect. Yes, good setup. Now, when I multiply both sides by z, get the z out of the denominator. So you're going to show you here, I'll write it. So times z, we'll do a times z there too. Okay? So those z's cancel. This z is here, so now we're going to have z sine of 8 equals 2.3. Right? So far so good? Now what's with the z that we need to get rid of? We want the z by itself, right? We want to have this z equals and then something. So what's with the z here that we need to get rid of? The sine of 8. So we're going to divide. It's the z times the sine of 8. We're going to divide both sides by sine of 8. Okay. Those cancel. Right, both cancel there. So what was z? And then you calculate. Now you can figure out what that value is going to be. Okay, so we want to solve for z. Okay, what is z? What side is that in our right triangle here? It's the hypotenuse. Okay, so we need to use a trig ratio that involves hypotenuse. So you can throw out tangent, right? Because it's not a hypotenuse. Either side or cosine. Okay, let's use this angle since that's what we're given. Okay, now this angle, we also know this side. What is this side in relationship to this angle? It's the opposite leg, adjacent leg, the opposite, right? So we have opposite leg. We also want to find hypotenuse. What trig ratio relates this angle, its opposite leg, and hypotenuse? So we're going to write sine of what angle? Equals, what's your ratio? What over what? Sine is the opposite leg, which is, what's the opposite leg? This is your angle, right? What's the leg opposite that angle? 2.3 over, which is the unfifteen. Now you're going to multiply the z over and then, solve from there, okay? Don't want to use tangent here. Tangent would be opposite leg over the adjacent side, which is this leg right here, which we're not going to solve the question. So we'll use a trig ratio that has opposite and hypotenuse. Which trig ratio has both opposite and hypotenuse? Like you see up there. Yeah, yep. Type it in. Well, what do you see there? 2.3 divided by, right? Voila, that's it. Good job. Good. Equals what over what? Sine is what over what? Sine is the opposite leg. Over hypotenuse. Good. Good. Yeah, good job. Okay. Fun times, right? Good job. See the Grace? Well, what's with the C here that you need to get rid of? Divide both sides by what? Okay. C sine of 8 equals 2 over 3. And you want to get C by itself. So what should you divide both sides by? Sine. So sine of 8, yeah. And then do that in your calculator. Okay, good. All right, folks. Okay, this is not necessarily easy. It's maybe a little uncomfortable right now, but it will get easier. It will get easier, I promise. Okay, we should have gotten 16.5. There's really two paths that you could take here to get that 16.5. Either you can use sine of 8 degrees, or you can use the cosine of the 82-degree acute angle here. Okay, you really wouldn't want to use tangent here. And the reason for that is because of the information that we're given. Tangent, okay, involves opposite and adjacent. Right? The opposite leg and the adjacent leg of these acute angles. Well, we're trying to find the hypotenuse. So tangent is not going to relate the thing that we're trying to solve for here, the hypotenuse. So we need to use either sine or cosine. Okay? So I think sine is the most straightforward way to go about it, doing it here, because you have this 8-degree angle. And what do you have in relationship to that 8-degree angle? You have this opposite leg, and you want to find the hypotenuse. So what involves both an opposite leg and a hypotenuse? It is sine. So sine is what you want to use here. Okay? You could use cosine if you found the 82-degree angle there, and then that would be the adjacent leg to the 82 over the hypotenuse of C. Two options, but really you don't want to use tangent. Tangent wouldn't be helpful. You could use tangent if you wanted to, because that could help you find BA, and then you could use the Pythagorean theorem between these two to get the hypotenuse. So Emmanuel, do you have a question? You'd use hypotenuse, and okay. So that would work, and I apologize, Emmanuel. I should have let you, I took the wind out of your sails there. But good, good. So that is an option. You could use tangent here, get the missing leg, and then use Pythagorean theorem to get the hypotenuse. And I apologize if that's what some of you guys are trying to do, and I steered you a different direction there, okay? Because that would work. Okay, so good, Emmanuel. Thank you for pointing that out. All right, last thing here, of course, we can also solve for angles just like we do with tangent, okay? I'm not sure why the book splits up tangent, sine, and cosine. Really, they all should be put together, okay? So try not to think of these as like tangent and sine and cosine, but just think of them as tangent, sine, and cosine all together. We can use them all, okay? So looking here, okay, let's say we want to try and solve, for example, angle A here, okay? Angle A, all right, how can we relate angle A with this side and this side? Well, 5 is what in relationship to angle A? Opposite leg, and 10 is the hypotenuse. So what trig ratio involves both opposite and hypotenuse? Sine. So we'll say sine of A equals opposite 5 over adjacent leg 10. You can call that 1/2 if you want to. How do we get this A by itself? What command should we use? We're going to use sine inverse. We'll say A equals, just like we use tangent inverse, we use sine inverse of 5/10 or 0.5. Okay, so second sine, 5 over 10. Okay, you could also say second sine of 0.5 if you want to. And look at that, we get a nice angle, 30 degrees. Okay. So then what does angle C have to be? It's going to have to be 60, right? But let's go ahead and set it up just to make sure. What trig ratio could I use here to find angle C? What is 5 in relationship to angle C? Adjacent leg, and 10 is the hypotenuse. So what trig ratio uses adjacent and hypotenuse? Cosine. So you could also say cosine inverse of 5 over 10, adjacent over hypotenuse there, and that's going to give us the 60. Okay? Cosine of C equals 5 over 10, which then yields that. Okay, so that's the idea there. Again, just using the inverse trig for those. Questions on any of that? All right, let's do the your turn together, and then I'll cut you guys loose on the homework here, okay? So one more here, okay? Triangle X, Y, Z. Let's just try this one together, and then we'll get you guys started on your assignment, okay? All right, let's go to Dylan. So Dylan, number 13 here. If we want to find angle Y, okay, what is this side in relationship to the angle Y here? Is it the opposite leg, adjacent leg, or the hypotenuse? Adjacent. So let me just write this out here. And then what is the 23? Opposite, adjacent, or hypotenuse? So what trig ratio has adjacent and hypotenuse? So we're going to use cosine. So we'll say cosine of y equals 14 over 23. Which then means that the measure of angle y equals cosine inverse of 14 over 23. Okay, second cosine 14 over 23. And we get about 52.5. Okay. Is it necessary for us to use trigonometry to find angle z? Do we need to use trigonometry to find angle z? No. We know what angle y is. We know what angle x is. We can find angle z. But let's just go ahead and use some trig just to make sure we are correct. So let's go to someone we haven't heard from yet, maybe. All right, Marty, you want to give a shot here to try and set up for number 14? If we want to find angle z, okay, 14, this side right here, is that opposite leg, adjacent leg, or the hypotenuse to angle z? Opposite leg. Very good. Okay. 23 is the opposite leg, adjacent leg, or hypotenuse of the right triangle. Correct? So we have the opposite leg, we have the hypotenuse. So what trig ratio here uses opposite leg and hypotenuse? The O and the H. So opposite O, hypotenuse H, it's sine. Do you see it there? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Do you see how the letters there work out and stuff? So we want to use sine. So we'll say sine of z equals opposite leg 14 over 23. Okay, so far so good. And so then we do sine inverse. Okay, so second sine, 14 over 23, and we get about 37.5. Okay, which shouldn't surprise us because that is the complement to the 52.5 there. Alrighty. So, without further ado, let me get you guys started on your assignment. You can get some time to work on that here in class with me around to help if necessary. Okay, so starting on page 703, I like you to do number 1, then 3 through 5. Nine through 15 odds. So it's 9, 11, 13, 15. And let's see here. Let's have you do number 19 as well. Okay, yep, that'll work. Question.
Can you say what percent and then also
Yes.